Welcome to today's AM Academy webinar, part of our ongoing series that's designed to make cutting-edge materials science and engineering knowledge more accessible. My name is Zara and I'll be your host for this session. And today's talk is on From Lab to Market, Navigating the Nanomaterials Commercialization Journey. And I'm very pleased to introduce Dr. Nobi Kambe, who is an advisor at Accelerated Materials. And in this session, Nobi will explore key market opportunities and unmet needs where nanomaterials can make an impact, common execution risks that hinder successful commercializations and how to mitigate them, the role of ecosystems, partnerships, and startups in scaling disruptive nanotech solutions, practical frameworks for startups that are navigating the complex journey from scientific breakthrough to commercial success, and some lessons that have been learned from one of Silicon Valley's first nanotech ventures. We'll also leave some time at the end for a Q&A, so feel free to drop your questions into the Q&A box throughout the session. And with that, I'll hand over to Nobi to begin.
And let me sharing. Thank you so much. So, hello everyone. My title today is From the Lab to Market. It's exciting and a very complex journey. So I'm very pleased to share what I've learned in my previous nano venture careers up to now. First, as you may know, material science covers nanotechnology side. This is the chart we have covered in our current places in the past 1 decade period. Engineered materials like ceramics, catalysts, membranes, some others, and nanotechnologies, obviously fluorines, graphenes, nanotubes, quantum dots, and many others. Then methods to make those or apply those materials for the useful devices. And as you can imagine from here, you can see lots of the industrial application opportunities from life sciences to environmental, energy, IT spaces. I always started with this chart 30 years ago when we started our nanotech ventures in Silicon Valley. And the nano is small, right? Analogy-wise, nanogram versus gram is corresponding to golf balls to the Earth. It's huge. By the way, Nanogram is the name of the company we created in the Silicon Valley nearly 30 years ago. Why it's so interesting? When you reduce the size of nanomaterials, materials, and then you can see emerging performances and new physical or chemical, biological, mechanical properties. That's the reason why people were intrigued by this. And basically, as you may know, nanoscience started by several people, including Richard Feynman in the late 50s. So already 65, nearly 7 years passed. So lots of the accumulations in knowledge. Now we are in the nano application era. Why nano? This is my personal interest. How to observe or understand the smallest functional unit of materials when you reduce the size. And not just atoms and molecules. Certain range of the size is important. When you see the 1 nanometer, 10 nanometer range, you can see a lot of the emerging properties. That's the reason why it's very interesting. And for example, right-hand side, you can see the gold. Gold, this is a very well-known papers a long time ago. As you reduce the size of gold metals down to 2 nanometers, 1 nanometer range, and gold metals can melt on your palm. or body temperatures. The same applies to silicon and some others. Several key IPs have been filed in the past for these properties. Now, once you understand those properties, now you want to create devices or systems out of these blocks. So we call it a nano Lego at the time, nearly 25 years ago. When you assemble nanomaterials like this in one directions in the periodic structures, and it's 1D, and if you making the periodic structures to two-dimensional and 2D and three-dimensional, then you can find very different performance in the functionalities of these nanostructures. That's a very interesting part of the nanosciences. So you can find a lot of nano benefits and opportunities. I'm using this chart today. I made this chart nearly 30 years ago, still usable. At the time, I categorized and benefits in three areas. Classic benefits, it's more of surface effects. Imagine you have 1 cubic centimeter sugar cube and cut it into tiny 1 cubic nanometer size cube, then sprinkle over the ground, then you can fill with sugars, almost a small baseball game stadium. So that much increase in the surface. So surface properties, basically the nanomaterials are surface materials in a sense. And immediately at the time, the people were attracted to for the application for the catalytic functions or coatings. And when you have this size and you don't have, you're gonna have macroscopic defects like dislocation. Therefore, intrinsically, each nanoparticle is the hardest materials for individual composition matter. Soft matter benefit is also interesting. And when you reduce the size of the inorganic materials to 10 nanometers or less, then you can find a great matching in the size with the even biological the materials like proteins, some others. And so you can make very nice organic, inorganic hybrid materials and also biosensors or bio-nanofusions just started around that time. The third category is quantum benefit. I'm a quantum guy, so I'm very much intrigued in here. And in your daily life, we have seen LED lamp or LED laser diode or solar cells and phosphor in your smartphones. Those are based on quantum mechanics. And now, because of the AI booming and the AI infrastructure is very important, the market space and how to reduce the energy consumptions in the data center and other places, infrastructures, and optics and electrons combined integrated circuits, or just bring in a photonic, silicon photonics, some others, all are quantum level of the benefits, including, of course, quantum computing, quantum network. If you look at individual materials compositions, I showed just a list of the typical ceramic materials and oxides, and also the metals and the carbides, nitrides, and sulfides. Initially, at the time, maybe 25 years ago, and people were very much interested in these oxide materials and for the battery applications. You may now remember 1996 and 1997, and that's the first time that people was able to use the handheld phones that contains lithium-ion batteries. Now lithium-ion batteries are much, much smaller. And thanks to the bringing the introduction of the nanoscale materials and the tiny the anodes, cathodes, and separator materials. And for example, nitrides. Nitrides is very interesting these days. For example, silicon nitride. This is refocused for the photonics side these days. And silicon photonics is it can get lots of benefit out of these materials. For example, iron nitrides. And this nation, many of you are globally playing. So and particularly in the States. And this materials is now very important materials, and for the next generation permanent magnets and for the motors. And without using the rare earth materials, carbon nitrile you have been already used, and also for the future power devices and some others. So you can see lots of the compositions, and combined with the nano size, you can see lots of the opportunities here. Now, opportunities are great, but how do you bring this profound science and technology into the marketplace? That's a question. Overall, commercialization journey is like de-risking journey. How to reduce the following risks. I listed just the major risks here, and I explained bit by bit, just briefly. Technology risk, obviously. POC, proof of concept. Validation by the third parties. Actually, people do not focus on the validation by third parties when you come to the venture capitals or angels or other investors. Validation by the third party is very important. We always hear kind of great or maybe the world the best performance or functionalities at the lab level in-house, not by the third parties. By the third parties, that's very, if you have this validation, it's a good indication of your materials for the potential commercially viable market. Eventually, all material sciences, not limited to nanomaterials, the entrepreneurs, they face scale and cost issues. This is a must requirement for the commercial viable applications. And I will touch on that a bit later on, a bit more. NIP, freedom to operate, this is very must, particularly in the current, the high-end, the materials and the application areas. Another important risk item is the market. Market size, the growth in the future, short-term and long-term, and competitions within the same market space and supply chains, how complex it is, and alternatives. Alternatives is very interesting, the risk. And sometimes, for example, you focus on the market A, but the market B and market C guys may take over your target market eventually. So it's not simple to just look at the single market that you want to pursue. You have to consider the other risks from the other marketplaces and go-to-market strategies and technology fits. This technology fit is very important. Not many people know it and learned it in the past. So I will touch on this a little bit later. Business model. You want to do product business, technology business, or license business, or subscription like a SaaS. And even in the hardware, the material spaces and SaaS-like model works out in many cases, or combined. In my observations, many companies have adopted combined or hybrid approaches these days. Team must be good enough, to be honest. And if you're entrepreneurs and the CEO or CTO, you must be visionary and executor, and you must be good team builders, and you must have a high level of integrities and learning capabilities. And at the beginning of the startups, and the number of employees is small, so CTO, CEO have to do everything. And at the same time, CEO, CTO can learn a lot. That's the benefit of this challenge. Financial risk, realistic CapEx and OpEx plan. This is a very difficult one, particularly for the first timers, the technologies, CEO, as the founders. And more important is actually follow-on investment. Follow-on investment cannot be done unless you achieve the milestone you promised to achieve in the previous round. Or if you can find great customers, potential acquirers during the previous round, and then maybe you can find very high value fundraising here. So there are many risk items. So just one by one or group by group. And it's just a de-risking challenge in journeys. For example, IT's cases, if you have target products like smartphones and components inside, or AR, VR, and in these areas, and OEMs are huge, right? And then you are in the upstream side, and as a spin out from universities, for example, or large companies, you are dealing with the nanomaterials or formulations or both. And then you have to deal with the device manufacturers, integrators, and up to OEM. At each point, you have to go through the qualification. So this is very long-term challenge, and also lots of the risk associated with this transition. So here is my observation. How complex is the supply chain? This is the must item to you. You have to check. The shorter, the better. Shorter, the better. For example, biopharma cases. And biopharma cases, you don't have many tiers here. Rather simple. You have biomaterials or bioprocessing technologies and directly connects to OEMs. But at the same time, you may need long-term in this single supply chains, and like FDA approval, some others. So, the EU needs to consider, not only just a shorter or shorter long supply chain, but also the total length to the market. So in this supply chain, where do you play? You want to play just the upstream material space or formulations, or you want to place partially the device side or system integration side? If you have, for example, in this case, if you have some architectures, device architectures and IP, and then you have the proprietary nanomaterials that enables those architectures, and you will be in good positions to negotiate with those people. You may be able to control your higher tier companies, mostly large companies. And whatever happens, and wherever it is, major technology hurdle is scale and manufacturability, and eventually cost. As I mentioned before, cost is everything toward the end, and you don't need to disclose cost to your customers, right? But you must be very careful about cost analysis and try to make lower, the lowest possible cost. And then you can enjoy nice margin, and you can be profitable very quickly. Now, in this kind of the multiple layers in a supply chain, partnership is very important. For example, if you can make direct contact with OEM, and actually very often OEM is always shopping the new innovations, particularly the upstreams. So if you can find the great OEMs, or if an OEM contacts you, then maybe that's a very interesting high value partnership at the beginning. If you can solidify the kind of qualification route from the OEM, then maybe you can control the device manufacturers integration level of the tiers. So you may be in a much better positions to manage this supply chain. I mentioned the market risk. Market risk is very huge. So this is a chart I made, again, maybe 25 years ago. And this is a market opportunity mapping. I made the multiples of them. And this one is just focused on silicon platforms. And you have, well, at the time we had multiple forms of the silicon materials or compounds. The micron size or amorphous size silicons, polysilicons, and silicon nitrides, or doped silicons, or hollow silica, or silicon and silicon oxide, and with X less than 1. This silicon oxide is conductive. So in many cases, people in the battery space were interested in this kind of materials. And you may know this materials application, the battery application is very one of the forefront and currently in the battery space. So this 25-year-old chart still works, and with some modifications. Now, this is a mapping only. Now you have to choose right market for your target. This is a very difficult task, but you have to go through the detail, the market analysis, or using the market search results, and also I will explain how to do it a little bit later on, but you have to choose a market. Then, for example, if you choose this phosphorus for the smartphones, for example, then you have to make next action. The third action here, assessment of your technology fit to the market. This is the one people forget or people don't do, even the big companies. So, and if you are entrepreneurs, you can do much better work compared to the large companies if you do this assessment. I respect this Hilltop Consulting Group. I'm not sure if they're still existing, but this is a kind of scheme of the high de-risking the market, the opportunities. In general, you form maybe 3 or 4 men and women team from the different functionalities within the company. The obvious technology lead and marketing lead or business development lead or sales lead, and sometimes legal or accounting, and then executives. Since the startups are not big, so always I expect CEO or CTO is always involved in this. And then spending 3 weeks or 1 month You don't need to do every day, every other day, or maybe twice a week in 2 or 3 hours in discussing and about the selection of your market. The what I mentioned in the previous slides, market opportunity mapping, and then selections, and now selections discussions. This is very interesting. You can find very easily. This is very useful process, and everyone in the small teams has a different opinions on the market. Marketing people have different opinions, and technology people are generally optimistic and dreaming, and accounting, so legal people are generally conservative. Lots of the exceptions, and executives have to make a decision eventually. So you can find a lot of different opinions. That's one of the benefit. You can learn once this team converges into single conclusion, that means you are building very strong team within the company. Then finally, market technology fit. That's very, very important part. Then you make a confirmation. Afterwards, it's relatively simple, just making development, technical development, executions. Now, why do we do this? And just maximizing the company values. And so again, I put just 5 points here, but in addition to that, you can learn a lot and how to build the team strongly. Okay. I mentioned partnership. Partnership is powerful, very powerful support and tools for commercialization and de-risking. A lot of matters, not just limited to technology side, but lots of the business side as well. At each stage, for example, if you identify the 8 companies in your target market areas and active players, very credible players company, and maybe initially POC stage, and they want to test your samples, or they want to take a look at your IPs. Then if they agrees to it, both of you will move into joint developments, or sometimes together with the joint marketing. If that happens, and then you may be able to shortcut to the market. Customer acquisition can be done through your partner companies in most cases, because your partners companies have already several customers in their mindset. So then moving into qualification, design, win, and then moving into scale manufacturing. Scale manufacturing can be done in parallel. And lots of the joint development is focusing on scale and manufacturing. The cost analysis have to be done during that time. But again, you don't have to show the all secret sources and just working together, but just provide reasonable numbers. But you have to keep your detailed cost analysis in a secret. That's general practice. And mass production and exit. Sometimes your partner may acquire you, or working together to go into the public. So partnership is very, very useful, powerful tool. Now, you are and we are in a roller coaster life. If you happen to be in a startup business, I've seen many, many great CEOs in the startups and who have this sense, resilience. Long time ago, I used for other terms like never give up and some others catch. But I think right now I understand resilience is very, very good attribute to be leaders in startups and even in large companies. And if you feel challenging is fun, you're okay. And if appropriate, it's okay to pivot your business directions or technology development directions. And if you do it frequently, I'd be very skeptical. But if you make a major decisions for good reasons, it's great. And you are working for your teams and society and planet. And I tend to be very energetic and passionate and when I work for other people or the society. All right, so be resilient. Now, just one case study. For several reasons, I blocked several names, but this is the supply chains, the actual supply chains for the conductive film companies. And actually, these companies, the product has been in your smartphones in several brands already. So as I mentioned, you are in the upstream side, and then device technologies and assemblies. And as you can see here, it's not simple. It's not a single chain, supply chain. It's very complex. And even under the touch sensors here and base layer, the film coating, different players, and also for different OEMs, you have different channels and sometimes the same players, sometimes a mix. So you have to identify the whole supply chain very carefully, then who to work with as a partners. That's very, very key in this business. And for energy space, the same, which battery manufacturer, cell manufacturer to work with, or battery application companies or electric vehicles or grid players to work with, and your potential fit for the business success is determined. So partnership is again very, very important. For the startups who are playing in the deep tech, and this is the diagrams in the US case, and there are several significant and ecosystems already built. When we started our nanotechnology ventures in nearly less than 30 years ago, there was no such ecosystem. So that's the reason why we have to start with to explain what nano means. Okay, now you have these luxuries. Why not using them? Again, this is a US case, and you may know this, the organization Chain Reaction Innovations. It's Argons and under the University of Chicago, the Engine, MIT, StartX, Tomcat, Stanford. Activate used to be the name Cyclotron Road, and they have an office in the Lawrence Berkeley National Laboratories, and they are also supported by DOE and also the or DAPA or corporates. And what they do, you are here, startups are here in the entrepreneur programs, and these organizations facilitates in laboratory or facilities available on the campus of the universities and national laboratories they are affiliated with. And at the same time, you can get sizable funding from the DOE government or states governments or corporates together. For example, chain reaction innovations, at least until the 5 or 6 years ago, they were DOE, 100% DOE government money, and they might have changed, I don't know. I need to check. But Activate, for example, is supported by all three the CAT class of the investors. So you can enjoy maybe 1 year, 2 years, and hiring 2 or 3 guys, and to grow to the stage where you can raise some VC money. And so these organizations are forming very, very important ecosystems for deep tech. Another ecosystem is obviously the professional investors. I found this diagrams in this group located in Tokyo and backed by the Mitsubishi trading firms. I don't know personally about these groups, and but this diagrams is a very good indication of what kind of business you have to knock the door. They see the capital supplies in a gap between R&D and validation phase and kind of maturity advanced stage into very close to the market. So this is the kind of the sweet spot for them to support. And they understand the risk associated with one and also the higher risk, the opportunity there too. And so, in their terms, it's a little bit different from my terminology, is the commercialization phase. I covered the commercial phase up to this, but they used only this one. But I covered the scale, also the part of the commercialization phase. And Phoenix Venture is also risk-taking and very much focusing on the advanced materials space. And so we have most of us are PhDs in materials space and but materials enabled industries places and C-level executive experiences. So if you are interested in that, and just let us know. Now, very close to the end of the story. I mentioned at early slide the timing and the business model risk it's potentially big. This is the relatively old data analysis made by this group, very well-known group, and for the hardware, the startups. And they said consumer hardware, so it's not limited to the nanoscale, but that can apply, I believe. Even I can tell this applies to energy space, battery, and other spaces as well. So in this case, first financial round, investment round, and they got 382, the base, the numbers. And then in the next follow-on investment, the successful companies to raise funds is just only 24%, just 1/4. And then successful A1 and exit is just 5, very tiny numbers. Then if you want to go further to raise funds in the third round, and the success rate is much, much lower, then exit is this almost the same level. But if you say the first one is series seed, then the second one means A, and third one is B. And then beyond that, actually, you cannot see any successful exit. So it seems great to raise a lot of funds, but it's not that great. You need a balance. And if you spend too much time and also too much capitals, and then you may increase the risk of failure. That's my point. Now, final slides. Final message. Timing is everything. When you start the new business, And in my case, though, we always started at the nanotech ventures at the relatively down time of the economy. Funny to say that. And but because of that, we were able to get a very good investment from the very serious and credible investors. So, the same applies to differently, vice versa. And then too much greed is not good. Fundraising is pretty rough, and if you raise too much, potentially you're losing the opportunity to just exit. And one more thing, technology-driven attitude. I'm a technologist, so I understand many of you feeling, and technology-centric attitudes no good for startups. Market-driven approaches. That works out. That's my real sense. Thank you.
Great. Thank you so much, Nobi, for that insightful session. We'll just give a few minutes for any questions to come through.
Mm-hmm.
So, Nobi, what do you see as the largest barrier for nanotechnology companies today?
Today,
Yeah.
well, universally, the technology, particularly the scale and cost, and the challenge is the biggest one. But at the same time, the 70% of the current investments in the new, the emerging areas in the AI space. So, you want to dance to AI boom, or you want to go beyond, and that's so the market analysis is more and more important for me. Did I ask? And if you have more questions, just please ask.
Can you elaborate on the role of AI in nanotech?
AI and?
Elaborate on the role of AI in nanotech.
Oh, AI and nanotech. Not many people are talking about this collaborations, actually, good match. As I mentioned earlier in some slides, like a silicon nitride for silicon photonics, or some new ceramics, and everything is in nanoscale, actually. And the photonics and electrons, fusions is a big trend, and sometimes optical fibers involved. But I think the key value proposition is in nanomaterials, nanoprocess, and nanostructure can reduce the energy consumption. So energy consumption is a very, very important part. And of course, energy spaces, batteries, or some grid applications as well. Oh, I think one more thing I should touch. What I mentioned today is just more of focusing on the startup companies, the stories, because AM is startups, and and also the challenging how to break the scale issues, and for the customers and who are mostly the large companies in many different market spaces. But some of the lessons that I mentioned is also applies to large companies, because I've been in large companies, and I'm still advising some national laboratories. So I think most people can understand, and particularly corporate planning people understand what I mentioned, I believe.
One more question. How do you see the funding situation across the world, not just the US?
Well, I try not to. We are not allowed to mention any the political things, but I think global economies has been changing, and lots of the uncertainties in the future, nearest future. But I should say, since I live in the Bay Area, Silicon Valley, and the innovation never dies. So it's universal, and in the intrinsically, the collaborations among the different nations and entrepreneurs and large companies still continuously moving forward. That's my understanding.
I think that's all of the questions we've
Sure.
got today. So thank you again, and thanks so much, Nobi, for that really great session. And thanks to everyone in the audience for joining us today. Just a quick reminder that this webinar is part of our ongoing AM Academy series, where we share knowledge and tools to help accelerate materials innovation. You can explore more webinars, articles, and technical resources at acceleratedmaterials.co/AM Academy. We'll also be sharing the recording on our YouTube channel shortly, so if you want to revisit any parts or share it with your colleagues, just keep an eye out. Thanks again for spending your time with us. We really appreciate it. Have a great day, everyone, and we hope to see you at the next AM Academy session.
Thank you for joining.